What is a computer? It's a machine that processes information. It takes data and instructions as input, processes them, and then gives us output. Think of it like a chef who takes raw ingredients, which is the data, and a recipe, which are the instructions, to create a delicious dish, the output. Computers come in all shapes and sizes. We can organize them into different categories. These categories help us understand their strengths and weaknesses. Understanding these classifications is important. It's like knowing the difference between a car, a truck, and a motorcycle. Each vehicle has a different purpose and use. Knowing these differences helps us choose the right tool for the job. Let's dive into the fascinating world of computer classifications. We'll explore their types, sizes, purposes, and functionalities. Get ready for an exciting journey. Computers can be classified into three main types: analog, digital, and hybrid. Each type has its own unique characteristics and applications, making them suitable for different tasks and industries. Analog computers represent data using continuous physical quantities. These computers are designed to handle data that changes smoothly and continuously, rather than in discrete steps. Imagine a speedometer. It uses a needle's position to show the car's speed. The needle moves smoothly across the dial, representing the continuous change in speed. Flight simulators are another example of analog computers. They use physical models to mimic the behavior of an aircraft. By simulating real-world conditions, they help pilots train for various scenarios. Digital computers, on the other hand, use discrete values, zeros and ones, to represent data. This binary system allows for precise and efficient data processing. They are like light switches that are either on or off. This binary nature makes digital computers incredibly reliable and versatile. Desktops, laptops, and smartphones are all examples of digital computers. These devices have become an integral part of our daily lives, enabling us to perform a wide range of tasks with ease. Hybrid computers combine the features of both analog and digital computers. They are designed to leverage the strengths of both types, providing a versatile solution for complex problems. They offer the best of both worlds. By integrating analog and digital components, hybrid computers can handle a wide range of data types and processing tasks. For example, some medical devices use analog sensors to measure vital signs like heart rate. These sensors provide continuous data that reflects the real-time condition of the patient. Then, they use digital components to process and display this information. This combination allows for accurate monitoring and analysis of the patient's health. Each type of computer has its own strengths and weaknesses. Analog computers excel in handling continuous data, making them ideal for simulations and real-time processing. Analog computers are good at handling continuous data. They are often used in scientific research and engineering applications where real-time data processing is crucial. Digital computers excel at processing discrete data. They are widely used in business, education, and entertainment due to their ability to perform complex calculations quickly and accurately. Hybrid computers bridge the gap between the two. By combining the continuous data handling of analog computers with the discrete data processing of digital computers, they offer a powerful and flexible solution for a variety of applications. Computers come in different sizes, just like buildings. From towering skyscrapers to small cottages, the world of computers is just as diverse. Each type of computer serves a unique purpose and fits into a specific niche. Much like how different buildings serve different functions in a city, we can classify them based on their size and processing power. This classification helps us understand their capabilities and the roles they play in various fields, from scientific research to everyday personal use. Let's start with the giants. These are the supercomputers, the behemoths of the computing world. Supercomputers are the most powerful computers in the world. They are designed to handle extremely complex calculations and process vast amounts of data at incredible speeds. They're like the skyscrapers of the computer world, towering above all other types of computers in terms of performance and capability. They can perform trillions of calculations per second. This immense processing power is crucial for tasks that require high precision and speed. IBM's Summit and NASA's supercomputers are prime examples. These machines are at the forefront of technological advancement, pushing the boundaries of what is possible. They're used for complex scientific simulations, weather forecasting, and research. These applications require immense computational power to model and predict complex systems accurately. Mainframe computers are smaller than supercomputers but still incredibly powerful. They are the workhorses of the business world, handling large-scale processing tasks with ease. Think of them as large office buildings. They may not reach the heights of skyscrapers, but they are essential for the smooth operation of many large organizations. They can handle massive amounts of data and support thousands of users simultaneously. This makes them ideal for industries that require reliable and efficient data processing. Banks and airlines rely on mainframe computers for their critical operations. These systems ensure that transactions are processed smoothly and that operations run without interruption. Minicomputers are smaller than mainframes. They offer a more compact and cost-effective solution for organizations that don't require the full power of a mainframe. They're like small businesses or university computer labs. These environments benefit from the balance of performance and affordability that mini-computers provide. They offer a good balance between cost and performance. This makes them a popular choice for educational institutions and small to medium-sized enterprises. They're often used by small and medium-sized businesses. These businesses need reliable computing power without the high costs associated with larger systems. Microcomputers are the smallest category. Despite their size, they are incredibly versatile and have become an integral part of our daily lives. These are our everyday computers like PCs, laptops, tablets, and even smartphones. They are designed for personal use and are capable of handling a wide range of tasks. They're compact, affordable, and perfect for personal use. Whether for work, entertainment, or communication, microcomputers have become indispensable tools in our modern world. Section 4. Computers with a purpose, general versus special. Computers can also be classified based on their intended purpose. There are two main categories: general purpose and special purpose computers. General purpose computers are designed to perform a wide range of tasks. They're like the multi-tools of the computer world. We use them for everything from browsing the internet and writing documents to playing games and watching movies. Offices and schools rely heavily on general-purpose computers. Special-purpose computers are designed for specific tasks. They're like specialized tools designed for one job. ATMs are a good example. They're designed specifically for banking transactions. Medical diagnostic machines are another example. They use computers to analyze images and data to help doctors diagnose diseases. Section 5. Functionality, first servers, workstations, and embedded systems. Another way to classify computers is by their functionality. This means looking at what specific tasks they are designed to perform and how they are optimized to handle those tasks efficiently. Let's explore three important categories: servers, workstations, and embedded systems. Each of these plays a unique and vital role in the world of computing. Servers are like the backbone of the internet. They are powerful machines that manage network resources and provide services to other computers. They store websites, data, and applications that we access online. Without servers, the internet as we know it wouldn't exist. They're also used for cloud computing. This allows for scalable and flexible resource management, enabling businesses to handle large amounts of data and traffic efficiently. Imagine them as giant libraries that hold vast amounts of information. Just like a library, servers organize and store data so it can be easily accessed when needed. Workstations are powerful computers designed for specific professional tasks. They are built to handle demanding applications that require significant processing power. They're like the heavy-duty trucks of the computer world. Just as a heavy-duty truck is built to carry large loads, workstations are built to handle heavy computational tasks. Engineers, architects, and video editors use workstations for their demanding applications. These professionals rely on the power and reliability of workstations to complete their complex projects. These computers have powerful processors and graphics cards for high-performance computing. This hardware allows them to run sophisticated software and perform tasks that regular computers can't handle. Embedded systems are hidden inside other devices. They are specialized computing systems that perform dedicated functions within larger systems. They're like the silent workers that power our world. These systems operate behind the scenes, making sure everything runs smoothly without us even noticing. We find them in cars, airplanes, smart TVs, and even refrigerators. Embedded systems are integral to the functionality of these devices, providing control and automation. They perform dedicated functions to make our lives easier and safer. From managing the temperature in our homes to controlling the navigation systems in our cars, embedded systems are everywhere. Each of these functionalities plays a crucial role in our modern world. Servers keep us connected by hosting the data and applications we rely on. Workstations empower professionals by providing the computing power needed for complex tasks. Embedded systems make our devices smarter and more efficient. Together, these systems form the foundation of our digital lives, enabling innovation and enhancing productivity.